on the AP exam, we have 3 types of questions. We have easy questions, we have medium questions, and then we have hard questions. Hard questions usually come in the form of choice 1, choice 2, choice 3, choice 1 and 2, choice 1 and 3, choice 1, 2, and 3, and then none of the above, right? So it's just like really time consuming. And then you have like a 4th type of question. It's called the tricky question, right? It's the question that's disguised as an easy question, but it's missing a semicolon, and like it's misleading, right? This question here, which is number 10 on page 20 in packet number 2, is a tricky question. Okay, so we look at this thing, and we see final, we see static. We're like thinking, we're thinking one way, and then we work that out, and we're like, okay, well, yeah, the instance field can be static and final and public, right? This is all fine. And then we work out the static double volume, and we're like, oh yeah, no, that's okay. That just means that if it's static, we don't need a object of type sphere to run volume, right? So if this is our code here, we would do it, but we would run volume by stating the name of the class sphere, right? Not creating an object of type sphere, but just naming the class sphere and then running volume on it and giving it whatever number we want, right? If we wanted to get the pi, it's just like math.pi, right? How do you do it? It's like you'd say the name of the class, math.pi, because pi is a static final variable in the math class, right? So we can have access to it without creating an object of type math. Okay, so this is how we would do it. All right, great. So this is fine. This is fine. Now we have the calculation, and now that you're thinking about the calculation, you're thinking, what about order of operations, right? Because that's probably what this question is centering around. And we're thinking, okay, well, we have division and multiplication. They are all in the same hierarchy of order of operations. So if they're all in the same hierarchy, we're moving from left to right, right? So we're doing 4 divided by 3, then that answer multiplied by pi, that answer multiplied by pow of radius to the 3. And since it's all multiplication division, it doesn't matter what order you do them in, you'll still get the same answer, right? So we're going through these answers here. Will not compile because no constructor defined. No, that's not true, because we learned about the default constructor, right? We don't need to define a constructor, because if there's no constructor, a default constructor will be created and all the instance fields will be set to 0 or null. And so that's not true. And then B, it will not compile because pi cannot be declared public. That's not true, man. If it's static, it has to be public, right? Because static means you can have access to it without actually creating an object of type sphere. So the only way to, I don't know how to explain this, but the only way to have access to it then from the driver is if it's public, right? If it's public, static, and final. Because if it was private and static and final, that means in order to access this pi variable, we would need to be inside one of the methods of the sphere class, which means we would need to have an object type sphere. So making it private and static is ridiculous. It's a pointless. You would just make it private, right? And so this is fine, right? And then D, this cannot be used because R is an int. That's not true, man. In math.pow takes in integers and fractions, right? So math.pow will work fine. And then E, you're thinking it's going to return a significantly smaller value than is expected from this equation. Well, this equation is the same as this equation, so what the heck's going on, right? And you're like, well, I don't know. I'm not too sure about static, so I'm going to answer C, right? But that's not true. And if you run this through a compiler, you'll notice that if you put a radius of 3 here and you run volume, you'll get 113, which is the correct answer. And then you run it using this code. Oh, I'm sorry. No, you run it using this code, and you'll get 87 as your answer, right? That's returned. You run it on a Google calculate volume of the sphere, and it gives you 113. And you're like, why? And the reason is because integer division is happening right here, right? We have 4 is an integer, 3 is an integer. So the answer to this expression here is not 1 point something something something. It is 1. Tricky, tricky, tricky. Beware.